So now let us do a experiment called Tyndall Effect. So for this experiment, we need a light source for which I am using my mobile, and we need a light probe that would sense the light and convert it to sound for people with the visual impairment to relate to the light. We also need three bottles in which we can keep water. So I have three bottles. Okay, I also have a tray with me. So you can see that I have a tray, three bottles, and some flour or sand, flour or sand, and some salt and a spoon. And I'm taking a bottle of water. I also have with me a little milk that I would be using during the experiment. So let us start. Now I am going to open the caps of this bottle. I'm keeping the bottles in the tray so that if the water spills, we still have our materials protected. So I'm going to pour water in one of the glasses. So I will pour, say, to half the bottle. So I'm going to move the bottle to a safe place, and I'm going to pour the water. Okay. So I poured it to two bottles. Now I'm pouring it to the third bottle. So I've almost poured the same amount of water in all the bottles. One of the bottle is going to remain as water. The second bottle I am adding a spoon of salt, giving a mix. Okay. Now I'm taking away the salt because we finished adding it. Now I'm going to take my third bottle. So first bottle is water, second bottle is water with salt, and I am taking the third bottle. I am adding a spoon of flour, that is atta, into it. You can also add sand, and I'm mixing after adding the atta. So we are going to leave it for some time. I'm removing all the bottles from the tray and keeping it aside. For this experiment, we will keep a tray between the light source and the light probe. The light probe will be opposite to the light source so that it can sense the light. The tray will be used to keep the bottles. Okay, now to start the experiment, I'm going to switch on my light source on my mobile and fix the source of light. I'm going to switch on the light probe and adjust it so that I can fix the path of the light where it is focusing the source. So this is the path where I hear the maximum sound. So now the source of light is fixed, and so is the light probe. Yeah, I can hear the maximum sound. I'm going to set this part. Now I'm going to keep our first bottle which had plain water. Let's see. Since it's plain water, all the light passes through it and you can hear a loud sound. Now I am going to take the first bottle out and keep the second bottle where we had mixed salt. So this is the salt solution. So you can see that the salt solution is almost similar to the water because it's clear. Salt has dissolved, it's clear water, and all the light passes through it, and you can hear a loud sound too. Now, the third bottle where flour was added to the bottle, you can see that the flour has sedimented, settled down, and you have mm, the water above that, which has some small particles of the flour that are suspended. So, this is a suspension, and you can see that the light sound has reduced. I'm going to take out this and put back our first bottle which had plain water. Now for this plain water I am going to add a spoon of milk. Let us see what happens to this sound as I add milk and mix to it. So I've added milk. When milk mixes with water, it forms a colloid. Since it's a colloid, all the ray which enter the bottle are scattered and very little light passes out of this solution, and so this is called as the Tyndall effect, and you can see that the sound is very mild. So this is the Tyndall effect. Let's quickly hear to all the sounds. So this is the bottle with salt solution, and then followed by the solution in which the flour was added, flour or sand, in which both sediments, and you have the particles suspended above. Now this is going to be replaced with the milk. So this is the Tyndall effect.